Every smartphone in your pocket contains a $5 component that sparked a $200 billion trade war and just became the new nuclear deterrent. Think about that for a second. The device you're using right now to watch this video contains technology so strategically important that it triggers fighter jet scrambles when shipments cross certain borders. We're talking about semiconductor chips, those tiny silicon wafers that power everything from your coffee maker to cruise missiles. And right now, the world's two largest economies are locked in an all-out battle for control over who gets to make them, who gets to buy them, and who gets left behind in the dust of technological history. This isn't just another trade dispute. This is economic warfare at its most sophisticated, where export licenses have replaced embargoes, and lithography machines have become more tightly controlled than weapons-grade uranium. The stakes? Nothing less than the future of global technological supremacy. Let me put this in perspective. China now spends more money importing computer chips than the entire world spends on arms sales combined. We're talking about $350 billion worth of semiconductors flowing into Chinese factories every single year. Or at least that's what it was until recently. In 2025, for the first time in 2 decades, China's chip imports actually fell by 15.4%. Why? Because the United States decided to weaponize the semiconductor supply chain in ways that would make Cold War strategists jealous. The strategy is elegantly brutal in its simplicity. Instead of trying to compete with China's manufacturing might head-on, the US identified what military planners call choke points, those critical bottlenecks where a small amount of pressure can bring an entire system to its knees. And in the semiconductor world, there's no choke point tighter than extreme ultraviolet lithography machines. These bus-sized $300 million machines are the only way to manufacture chips smaller than 7 nanometers. There's exactly one company in the world that makes them, ASML in the Netherlands. And as of October 2022, they're banned from selling their most advanced models to China. But it goes deeper than that. The US didn't just block the machines themselves. They blocked the components, the software, the servicing, even the knowledge transfer. Any company, anywhere in the world, that uses American technology in their products, which is basically everyone in the semiconductor industry, now needs US permission to sell to certain Chinese companies. The immediate impact was devastating. When US agents seized a single suitcase of lithography blueprints at San Francisco International Airport in 2023, intelligence analysts estimated it delayed China's chip ambitions by 1,825 days. That's 5 years of progress confiscated in a piece of carry-on luggage. Nvidia's most advanced AI chips, the H100 and A100 GPUs that power artificial intelligence systems, completely banned. Manufacturing equipment for anything below 14 nanometers blocked. Even American citizens aren't allowed to work at Chinese semiconductor companies without explicit government approval. The Dutch government, under US pressure, blocked 20 EUV shipments to Yangtze Memory in 2024 alone. Japan joined the alliance, restricting their own advanced semiconductor equipment exports. It's a technological iron curtain, drawn not across Europe, but through the heart of East Asia's supply chains. But here's where it gets interesting. Because if history teaches us anything, it's that necessity is the mother of invention. And China's response to these restrictions has been nothing short of extraordinary. Enter the Big Fund 3, China's $75 billion war chest, specifically targeting semiconductor equipment and material suppliers. This isn't just government spending. This is a coordinated industrial policy on a scale that would make the Apollo program look like a weekend hobby project. SMIC, China's largest chip manufacturer, just achieved something that industry experts said was impossible. They're producing 7-nanometer chips, the same technology that powers the latest iPhones, using older deep ultraviolet lithography equipment. How? Through a process called multi-patterning, where they essentially run the same chip through the manufacturing process multiple times to achieve finer details. It's inefficient, it's expensive. Each chip costs roughly 40% more to produce than its Western equivalent. But it works. SMIC's Shanghai fab, an $8.9 billion investment, is now churning out 35,000 wafers per month at 7-nanometer density. Huawei's latest Kirin 9100 processor, found in their flagship smartphones, proves the point. Despite being cut off from Taiwan's TSMC, the world's most advanced chip manufacturer, Huawei managed to create a processor that benchmarks within 15% of its Western competitors. They did it through brute force engineering, innovative chip stacking techniques that layer 14-nanometer performance to simulate 28-nanometer capabilities, and by throwing money at the problem until it went away. The talent acquisition has been just as aggressive. Since 2021, Chinese companies have recruited over 30,000 semiconductor engineers from Taiwan and South Korea. They're offering salaries 3 to 5 times the regional average, housing allowances, and in some cases even private schooling for employees' children. It's a brain drain that has Taiwan so worried they've made it illegal for their citizens to work at certain Chinese semiconductor companies. But China isn't just trying to catch up to today's technology. They're betting big on tomorrow's. While the US and its allies control the current generation of silicon-based semiconductors, China is pouring $15 billion into quantum computing research, more than 8 times the US National Quantum Initiative budget. Their Zhujiang 3.0 quantum computer, with its 113 photon processing capability, is already solving certain problems that would take classical supercomputers millennia to complete. The race for next-generation computing isn't just about quantum, though. Neuromorphic chips that mimic human brain architecture, photonic processors that compute with light instead of electrons, and new materials like gallium nitride that offer 20% better power efficiency. These are the battlegrounds where neither side has a decisive advantage yet. Intel's Loihi 2 neuromorphic processor and Lightmatter's photonic computing platform represent Western bets on these emerging technologies. But for every American breakthrough, there's a Chinese team working on something similar, often with more funding and fewer regulatory constraints. The most fascinating development might be in advanced packaging, the art of combining multiple smaller chips into one super-powerful package. TSMC's 3D fabric technology enables what they call chiplet ecosystems, where different components can be mixed and matched like Lego blocks. It's a potential workaround for manufacturing limitations, allowing companies to achieve cutting-edge performance without cutting-edge fabrication. The advanced packaging market is projected to grow 78% by 2028, from $44 billion today. It's becoming the new frontier where China might actually leapfrog Western capabilities. But there's another card China's playing that might be their smartest move yet: RISC-V. This open-source chip architecture bypasses the licensing restrictions of ARM and Intel's x86. It's like Linux for processors, and China has embraced it wholesale. They're building entire ecosystems around a RISC-V, from smartphones to supercomputers, creating a parallel technology stack that's immune to Western export controls. All of this technological maneuvering comes at a cost, though, and not just for China. The chip restrictions have added between 3 and 7% to the price of consumer electronics globally. That smartphone in your pocket? It costs about $50 more than it would in a world without semiconductor sanctions. Your next laptop, gaming console, or smart TV, all carrying a hidden tax from this economic warfare. The CHIPS Act, America's $39 billion response to shore up domestic production, is running into its own problems. Intel's Arizona fab, originally scheduled to open in 2024, has been delayed to 2027. The clash between 500 Taiwanese technicians brought in by TSMC and US union regulations has turned what should be a simple factory construction into a cultural battlefield. The irony is thick enough to cut with a silicon wafer. The US, which spent decades offshoring chip production in the name of economic efficiency, now finds itself dependent on Taiwan for 92% of sub-5 nanometer chips. One geopolitical crisis in the Taiwan Strait, and every advanced product from F-35 fighters to PlayStation consoles grinds to a halt. Meanwhile, the very export controls designed to slow China's progress might be accelerating their innovation. When ASML can't sell them machines, they build their own. When Nvidia can't sell them GPUs, they design alternatives. When the West cuts them off from the semiconductor supply chain, they create a parallel one. Some industry analysts argue we're watching the birth of two separate technology ecosystems, a Western one built on established standards and supply chains, and a Chinese one built on necessity, massive state investment, and a willingness to accept inefficiency in exchange for independence. The question isn't whether China will catch up. With their current trajectory, most experts believe they'll achieve parity in conventional semiconductors by 2030. The question is whether the next paradigm shift in computing will make today's silicon supremacy as irrelevant as vacuum tubes. Quantum computing could make traditional encryption obsolete overnight. Photonic processors could make data centers 90% more energy efficient. Neuromorphic chips could enable AI systems that learn and adapt like human brains. Whoever wins these races won't just dominate the next decade of technology, they'll define how humanity computes for the next century. The chip war isn't really about chips, it's about who gets to build the future. Every export control, every billion-dollar fab investment, every recruited engineer is a move in a game where the board keeps changing and the rules are being written as we play. For investors, this presents both massive opportunities and existential risks. Companies exposed to Chinese markets face regulatory uncertainty. Those betting on reshoring face execution challenges. Those investing in next-generation technologies face the fundamental question of which horse to back in a race where the finish line keeps moving. For policymakers, the challenge is balancing economic security with innovation. Every restriction that protects today's advantage potentially cedes tomorrow's breakthrough to a competitor willing to invest more and regulate less. And for the rest of us, we're living through the most important technological competition in human history, where the winners will shape not just what devices we use, but how artificial intelligence develops, how quantum computers crack problems, and ultimately, how humanity's technological future unfolds. The chip war has only just begun. And unlike previous conflicts measured in territories gained or lost, this one will be measured in nanometers, qubits, and the fundamental question of who controls the means of computation in an increasingly digital world. If you want to understand how this battle shapes the technology in your pocket and the geopolitics of tomorrow, make sure to subscribe for our ongoing coverage of the semiconductor industry. Because in a world where chips are the new oil, understanding this conflict isn't just important, it's essential.